Hello students, in this video we will discuss an example on the variational principles. Okay, to find the ground state energy for the one-dimensional harmonic oscillator using the variational principles. Okay, so the variational principle is this one: is the ground state energy is approximately is less than or equal to the expectation of H or the Hamiltonians. Okay. So first we find the Hamiltonian of test, and then we minimize, so we find it's the ground state energy. Okay, we know the, so first we find the Hamiltonian of H. Okay, so we know the Hamiltonian for harmonic oscillator is equal to h cut square divided by 2m and d square divided by dx square plus 1/2 m omega square into x square. This is kinetic energy and this is a potential energy for harmonic oscillator. Okay, now we consider a wave function, or a vector wave function, and this wave function is called Gaussian wave functions. Okay, so this is equal to the psi of x is equal to a into e to the power minus bx square. Okay, and here a has the normalization constants while the v has the variational parameter, or we can say the adjustable parameter. Okay, now first we normalize this wave functions. Though the normalization condition is from minus infinity to positive infinity, psi of x mod square into dx. Okay, then this is from minus infinity to infinity of this mod square. Then this is a mod square and e to the power minus bx square into dx. Okay, now then a mod square and integration of this. Okay, minus 2bx square into dx. We know the integration from minus infinity to infinity of e to the power minus ax square dx is equal to, the its solution is equal to the phi divided by a under root. Okay, the its solution is this. Now, so then the its solutions is equal to a mod square, and its value is pi divided by 2b. Okay, here is 2b. Okay, now then, and under the normalization condition this value is equal to 1. Okay, and then the a mod square and phi divided by 2b is equal to 1. Then the value of a is equal to 2b divided by phi under root, and then I can, so the x is 1/4, power is 1/4. Okay, so we know the Hamiltonian of H is equal to the Hamiltonian of the kinetic energy and plus the potential energy. Okay, so we first find the expectation of kinetic energy. Okay, and the expectations of this kinetic energy is from minus infinity to positive infinity of psi steric, and then the kinetic energy of factor. Okay, and then the psi into dx. Okay, but then here we put the value of the psi, then a mod square, because this is 2 times, and then an e to the power minus bx square, and then the operator of t we can write in terms of momentums. Okay, so the its value is minus h cut square divided by 2m and d divided by dx square. This is operator. Okay, and e to the power minus bx square into dx. Okay, then this is constant, and minus h cut square divided by 2m, this is also constant, and then integration from minus infinity to positive infinity, a to the power minus bx square and t divided by dx square and a to the power minus bx square into dx. Okay, now we take the double derivative of test functions. So then minus the h cut square divided by 2m and a mod square, and then from in minus infinity to positive infinity, and this is a to the power minus bx square, and the x value is a to the power minus the bx square and 4 p square x square and minus the 2b a to the power minus bx square. Okay, and then dx. This is so simple. Okay, then minus h cut square divided by 2m, and then the value of a square is equal to 2b divided by pi 1 over half. Okay, okay, and then the integration from minus to positive infinity. Then we take e to the power minus bx square from this, then this is 2 times bx square, and then this is 4 b square x square minus 2b and dx. Okay, okay, minus h cut square divided by 2m and 2b divided by pi 1 half, and then integrations, and here we apply a separately to this two term, then this is 4 b square x square and a to the power minus 2b x square, and then minus 2b integration from positive infinity to negative infinity, and a to the power minus 2b x square into dx, and also here dx. And here we use the gamma function definitions, then we get for this, okay, for this integration, and this integration we have already done, so the its video is so simple. Then this is equal to minus h cut square divided by 2m and 2b divided by pi 1 half, and the x value is equal to 4b square. The x value is under root pi divided by 32 b square b cube, and then minus 2b and phi divided by 2b. Okay, this is phi divided by 2b. Okay, then when we simplify this value, then we will get the kinetic energy is equal to h cut square into b and divide by 2m. Okay, this is the expectations value of kinetic energy. Okay, okay, then we find the expectations of kinetic the potential energy. Okay, so the potential energy we can write directly. This is 1 over h to omega square and a mod square and integration from positive infinity to negative infinity, and x square and a to the power minus 2bx square into dx. Okay, here we only put the potentials value. Okay, it's so simple to the kinetic energy. Okay, but then we using here also this formula, the gamma function, then this is equal to the H video is equal to m omega square divided by 8p. Okay, this is the value of the potentials. Okay, then we know the H expectation is equal to the potential, the kinetic energy, and then the potential energy. Okay, so we put here the value of this two, then this is H cut square divided by v into b and divided by 2m plus m omega square divided by 8p. Okay, now we minimize this potentials to obtain the ground state energy. Okay, then we can write like here. Then the expectation of H is equal to H cut square V divided by 2m plus m omega square divided by 8p. Okay, now we minimize this potentials, this Hamiltonian, then we take derivative of S. Then this is the, and we take the X derivative with respect to the adjustable parameter. Okay, here the adjustable parameter and the wave function is b. Okay, then this one, and this is equal to 0. Then we take the X derivative with respect to b, then we will get this is H cut square divided by 2m. Okay, the derivative of b is equal to 1, and then minus m omega square divided by 8b square. Okay, the derivative of this is equal to this. This is minus b, then we take the X derivative, then the minus 1 and here, and then minus 2. Okay, then we will get this as equal to 0. Okay, and here we find the value of v is equal to, we simplify this value, then the value of the b is plus minus the m omega divided by 2h cut. Okay, here the value of the b is 2 value. Okay, so then we find the one of these is a minimum value. Okay, then we take the X derivative against this, we take the double derivative of this to find the minimum of this Hamiltonians. Okay, then we take here, this is d divided by db square of the H. Okay, so first we take the X derivative first time, then we again take the H derivative, then this is equal to the this is 0. Okay, and then minus, and then this is equal to m omega square divided by 8 and minus 2 and then minus b cubes. Okay, and then this is equal to m omega square divided by 4b cubes. Okay, we can simplify, just cut, and this is cancelled to this, then there here is 4. Okay, then we put the value of the p, let's say, and this is b1 is m omega divided by 2h cut, and the b2 is equal to m omega divided by minus, okay, and 2h cuts. Okay, then the double derivative of the expectations value is equal to this one, is m omega square divided by 4b cubes. Okay, Then we put the value of the B1, B2 at the point first B1s. Okay, then we will get the its value is positive. Okay, and when the double derivative is positive, this means that this is minima. Okay, this is minima. When we put the value of this and the Hamiltonians, so at a point B2, then we will get minus, and so this is maxima. So this value, so the first value is this B1 is the minimum values. Okay, now we put this value B1 into the Hamiltonian equation, into this equations. Okay, then the expectations of H is equal to H cut square divided by 2m, and the value of the B is this one. Okay, is m omega divided by 2h cut, and then plus m omega square divided by 8, and the value of P is 2h cut divided by m omega. Okay, then we simplify this equations to here the m is cancelled to this, and h cut is cancelled to this. Then this is 1 over 4 h cut omega. Okay, and plus this is also 1 over 4 h cut omega. Okay, then this is equal to 1/2 h cut omega. Okay, then this is the Hamiltonian, the ground state energy is approximate values. Okay, this is like approximate value. Okay, thank you.